Good morning to all. Now, so far, all contents of Unit 1 were discussed. Unit 1 is completed. Now, just we are going to begin with second unit. Let us start. Now just we are going to begin with Unit 2 of signal systems. In Unit 2, the major concepts are regarding Fourier series. The main concepts are regarding Fourier series. Students can 100% expect a numerical problem on this Fourier series. This contains mathematical contents, mathematical representation of signals, Fourier series. How to design a signal and what is the exponential representation of signals. All these things will be discussed in the next classes. So the content is regarding, in this unit, the content is regarding Fourier series. Now, let us start. In this series, so Unit 2, the Unit 2, the syllabus content is first analogy. The first concept is regarding analogy. After that, we continue our discussions with the concepts of Fourier series. Fourier series. So actually simply just we can make a segregation of syllabus or content of Unit 2 like this. Here analogy implies means what? The analogy between vectors and signals. Vectors and signals. This is the first topic just we have to begin with. After that, we will begin with these concepts, Fourier series. That thing we have to make it. Now let us start. So now the first concept is analogy, similarity. The similarity between vectors and signals. Vectors and signals. Now just come back. We already studied this vectors concept all previous semesters, and we already began in second paper of your intermediate, second year. Now regarding vectors, let A and B be two vectors, or V1, V2 be two vectors. You can represent anyway. There we already learnt some formulas, A dot B, A cross B, like that, or vector V1 dot vector V2, vector V1 cross vector V2. These type of representations we calculated, and we come to know all these things. Now here, do one thing. This is a vector, for example, V1. This is another vector, V2. A vector V1, this is another vector V2. Now, the projection of this vector is on the vector V1. That means what? The representation of V2 is in terms of V1 only. V2 doesn't have its own representation because it is focusing on which one? V1 only. Its projection is on V1 only. Therefore, the value, the componental value of this vector will be in terms of V1 only. For example, look at in this case. So, V2 is equal to, now the value of V2, it will be in the terms of V1 only. In the terms of V1 only. Therefore, how to represent this one? Similarly, the value of V1 will be in terms of V1. It will be in the terms of V1, but V2 will be in the terms of V1. Now just look at. V2 is equal to some constant into V1. Similarly, V1 is equal to some another constant into V1. This is the axis. V1 axis is different, component is different. On this V1, component value is some constant into the direction of the vector V1. Here, V2 is equal to some constant into the direction of the vector V1. Look at V1, V2. Both are representing in this way. Now, these projections, you can't say 100% accurate. Some errors may occur. For that purpose, you may add some error. Error 1. Here for this, you may add some error 2. What is these errors? These errors may be for addition or deduction of the output. If you get output more than the required, then the error will be for substitution, subtracting some value. If we get the error less than the required one, then this error will be in positive way to add, to come to the error. Understanding? So now, these are the vector representation V1, V2 like that. So here, for any representation, there is a small error, E, small error E1. Now just look at this is. So the projection, because of the projection of V2 on V1, V2 value will also be measured in terms of V1. V1 already, it doesn't have no projection parallel one. So directly V1 value will be V1 only. Now here just look at, here there poses some angle theta, but this angle, any value, but this theta angle is not equal to 90 degrees or pi by 2. Pi by 2. Understanding? Now come to this one. If two vectors V1 dot V2 is equal to mod V1 mod V2 and the angle between them that is equal to cos theta. That is a general formula to find the angle between two vectors. For example, look at theta equal to 0. If theta equal to 0, then what happens? Cos 0 equal to 1. In this case, V1 dot product of two vectors is just equal to their modulus, product of their modulus. Because cos 0 becomes 1. Here this is scalar quantity. Scalar quantity means what? Numeric value. For example, 3, 5, 72, 135, all these are numeric values. These are called scalars. Now, for example, here theta is equal to 90 degrees. 90 degrees means what? These two are perpendicular to each other. For example, just look at, this is the vector V1. Now here, the vector V2. Now these two are perpendicular. This is 90 degrees. Right angle triangle just like that. Degree is 90 degrees. These two are perpendicular like this. Understanding? In this case, cos 90 is what? Cos 90 value is how much? 0. 0 this much. Entire RHS will become 0. Then the output will be V1 dot V2 equal to 0. This is the special case. This is the special case. Look at. Two vectors are said to be perpendicular to each other if their dot product equal to 0. That is the vector point. Whenever the product, dot product, this is called dot product. Whenever the dot product of two vectors becomes 0, then these, the angle between these two vectors equal to 90 degrees. We use one specific word. That word is called orthogonal. This is called orthogonal. So these two vectors are said to be orthogonal. Orthogonal means what? Perpendicular to each other. Orthogonal means what? Orthogonal means perpendicular to each other. So what is now from this orthogonal word, we use another one, orthogonality. Now under this concept, analogy between vectors and signals, we are extracting one important principle. That principle is called principle of orthogonality. That thing now we are going to discuss in this session. So now here, orthogonality, we are focusing on this one. This is called orthogonality principle. Orthogonality principle. There is the analogy. What is the analogy between vectors and signals? Orthogonality principle. That thing now we are going to discuss. I am giving you in advance the name of the analogy between vectors and signals, that is called orthogonality. Now, how this orthogonality principle is in the same way, has the same mechanism between these two domains. Now, just we are going to discuss. Now, just look at. Now, just look at in the previous case, just we assumed V1 and V2 are two vectors. Now, here just look at F1 of t and F2 of t are two signals. Look at, there we use vectors. Here we are using signals, because in the first session, what we are expecting, what we are expecting from this analogy, what we are expecting means, just look at, these are vectors. This domain is vector domain. This domain is signals domain. Signals domain. Can we compare signals with vectors or vectors with signals? That is the main concept of this analogy. What is the common factor, common principle between these two different domains? Now just we are going to discuss, we are going to find out that domain. That domain is called what? Analogy. Analogy. Finding analogy. What is the analogy? That analogy is called orthogonality. That analogy is called orthogonality principle. That is called orthogonality principle. Now in this one we are going to study this orthogonality principle. Orthogonality principle. So now just look at, regarding vectors is concerned, V1 is a vector, V2 is a vector, and V1 dot V2 is a dot product. This is a dot product. Similarly, V1 cross V2 is a vector product. This is called a vector product. Now, dot product is always a scalar. Dot product is also scalar. Scalar means what? Number. Cross product is again a vector. Cross product is again a vector. This principle is used. This principle is used to verify whether vectors are perpendicular to each other. This principle is for perpendicularity principle. For perpendicularity, we are using this dot product. Now, this cross product, this is for parallelism, parallel vectors. This is for the parallel vectors we use. So you already learnt all these things in previous semesters, but I am making you remember to recollect all these important points, because in the very next session we are going to discuss with the signals. In the signals, how vectors can be clearly compared with the signals by using the principles of orthogonality. Because of that principle, now just we are excavating all these important points of vectors. So only 1 or 2 points, not more than that. Now taking all these into consideration, in the very next session we are going to discuss orthogonality principle of signals. Then we come to show that, now we will prove that these two are same on the basis of orthogonality. For that purpose we discussed so far. The remaining content we will be discussing in the next session. Thank you.